Problem 2-8. Consider the sequence with the initial value 256, followed by 64, then 16, and then so on. Write the next three terms of this sequence, then find an equation for the sequence. I'm going to list out my terms here. So right now, I'm going to list them in table form. So this will help me later on when I'm trying to write my equation. So I've got a sequence. I've got my first term in my sequence was 256. My second term in the sequence was 64. Oops, I'm sorry, I didn't mean to do that. Wasn't paying attention. So my second term was 64. The third term in the sequence was 16. And so they want us to find the next three. So what are the fourth, the fifth, and the sixth terms? Well, we can see that 256 and 64, when we take the difference between those two, it's different than 64 to 16. The difference here is 38. The difference here is about 196, I believe. 198, something like that, one of the two. But either way, it's different. So what we're going to have to look at here is what's another way to kind of compare the numbers. Well, I can say here that 64 when compared to 256, if I pull out my calculator here, and I'm going to go into just my regular mode. If I can do 64 divided by 256, see, it gives me 0.25 or 1/4. And if I take 16 and I compare it to 64 the same way, or do 16 divided by 64, it also equals 0.25. So we know here that 64 over 256 equals 1/4. And 16 divided by 64 also equals 1/4. If I divide each number by the number before it, I should get 1/4. So we could also think of that as saying 256 divided by 4 gives us 64. 64 divided by 4 gives us 16, or times 1/4. So we're saying times 1/4. And the reason I'm saying times 1/4 instead of dividing is because we're going to have a geometric sequence here, and we need to know what the multiplier is. So 16 times 1/4 gives us 4. 4 times our 1/4 again gives us 1. And then 1 times 1/4 gives us 1/4. So our next three terms in our sequence there are 4, 1, and 1/4. It says if you were to keep writing out more and more terms of the sequence, what would happen to the terms? Well, each time we're multiplying by 1/4, right? So in this case here, they're going to get smaller and smaller, but they're never going to reach 0 or become negative. I realize that may be hard to read. So it says they will continue to get smaller, but will never reach 0 or become negative. Oh, and I guess I was supposed to find my equation up here, so I overlooked that. So let's go ahead and do that real quick. If we want to come up with our equation, we're going to have to look at our terms that we have. If I'm going to need to come up with a function for t of n, so where my output is this number. Well, it's always good to look at, say, all right, I want to look at my 0 term. So if I took 256 and I went backwards here, I would have to multiply it by 4. 256 times 4 would be 1024, I do believe, and let's just double check that just to be safe. Yep, 1024. So we'd need to start at 1024, and then we would multiply that by 1/4 n number of times. So if I said 1024 times 1/4 one time, it would give me 256. If I took 1024 and I multiplied it by 1/4, and then I multiplied it by 1/4 again, so twice, I would be at 64. So you see how that works. Now another way this could be written, if you didn't want to use the 0th term, you could use this first term. You could also put down t of n equals, we could start here. I could say we're going to multiply it times 1/4. So if I wanted to end up with my first term being 256, and I plugged in 1 here, that means I would already have 256, and I would need to multiply it by 1, which means I would need to have 1/4 0 times. So the way you would represent something like that would be like n minus 1. Some people are taught this way, other people are taught this way. Both are correct. That is the answer for part A there, for the equation. We've already talked about B. Let's say sketch a graph of the sequence. What happens to the points as you go farther to the right? Here's what I'm going to do. I'm going to go on here and I'm going to graph it on a stat plot here. So you see I have some values in here already. I'm going to go up and clear them out. If you just highlight your list number, if you have something in there, press clear, it should clear it. I'm going to make this my input values and this my output values. In fact, let's just, since they say it starts with 256, let's go ahead and use that. So we're going to say 1, enter, 2, enter, 3, enter, 4, enter, 5, and 6. And make sure your corresponding values line up. So we got those here. Now to turn your stat plot on, you have to go second, y equals, and we're going into stat plots. So second, y equals, and we're going to go into number 1. We want to highlight on and press enter. And we want to use the stat plot. So that's what this type is. There's also line graphs, bar graphs, box and whisker plots, etc. So we're just focusing on this one. Our input value is our list 1. Our output value is list 2. So it looks like it's good to go. So let's go ahead here and press graph. And you'll see it'll have some of our points here, but maybe not all of them. So what you want to do is you want to go to zoom. And we want to do a zoom stat number 9. You see now it's got all of our points on there. So you see it's getting lower and lower and lower. It's getting closer and closer to the x-axis. So here's my sketch. Yes, I'm a cheetah. Oops, didn't mean to do that. There's our sketch there. As it's coming, it's going down more and more and more. So this is what happens to the points as you go farther to the right. Well, they're going to continue to get smaller and smaller and smaller. But they're never going to get to 0 again, and they're never going to be negative. So it's pretty much like the same answer we have as on the one before. Then it says, what is the domain of the sequence, and what is the domain of the function with the same equation as the sequence? So the sequence that's an E there. Our domain is going to be, think about it here. These are all the input values here. Do we have a term that's 1.5? Is there a point in between there? There's not going to be. So we're going to say that our domain is going to be all real integers greater than or equal to 0. All real number integers, or you could just say all integers that are greater than or equal to 0. Okay, or you could say whole numbers if you wanted to say that. That would be a good way to put it as well. And then our domain for the function, like we're just graphing this function on a calculator here, that equation, it's going to end up being all real numbers. And you'll see that here. I'll pull out my calculator again and show you that when I take it here and I graph the function that we came up with here, let's do this function here. We're going to say t of n, or y, equals 256. And then we're going to have times our multiplier, 1/4. And we're going to take that, oops, shoot. There we go. Okay, we're going to raise that to the power of n minus 1. Well, in this case, we're going to use x because we're plotting it on the calculator here. Take it, you look at the graph of that, you see it's going to connect and give us all of the possible input values that would work there. And it's going to be all real numbers because it should be any value that we could plug in to get that. So what is the domain? The domain is actually all real numbers, but for the sequence, we have term numbers that we use, so we skip over everything in between. Hopefully you remember that from Algebra 1. If not, hopefully that helped. If you have other additional questions, please make sure you ask your teacher. Thanks for watching.